This example shows a circle, centre the origin. There's a touching point here with a straight line, a point P, and we're asked eventually to find the coordinates of R. To do that, we need to find the equation of this line, the straight line here, going through P to R, and then, once we've got that equation, the point R is defined by the fact that y equals 0. But we've got to do a little bit of work before that. One of the biggest clues they've told us is that P lies on the circle, yes, okay, but it has an x-coordinate of 1. So this coordinate is, well, 1, and well, let's call it Q to stop any confusion. We don't know it at the moment, but we can find it out. Well, that point P is common to the circle as well, because both the y-coordinate and the x-coordinate of that point, well, we know that's 1, meet at point P. So we can substitute the value of x equals 1 into the circle equation, and that might help us along the way. Okay, so I can say that 1 squared plus q squared is equal to 17. Well, we've got an equation here just in q, which we can solve. We need q squared on its own, so the 1 squared is going to shift sides and become negative, because we're going to subtract 1 squared from both sides, well, 1 from both sides, and solve for q. So q squared is equal to 17 minus 1, so therefore q squared is equal to 16, and q is equal to plus or minus 4. But because the diagram tells us that we can reject the negative version of q, q is equal to 4, and p, therefore, is at the coordinates 1, 4. So we've actually got the coordinates of a point on our straight line, but to get the rest, we really need to find the gradient of the line. Well, to help us, what about the gradient of that line? We know that the base of this triangle formed here is 1, and the height is 4. So if you look at rise over run of the line here, the rise is 4 and the run is 1. So I can say gradient of OP is equal to 4. And we know that a radius and a tangent must meet at a right angle. So this angle up here is a right angle. Therefore, the line PR is perpendicular to the line OP. And the rule about perpendicular gradients is that I can say that the gradient of the line, well, let's call it the line PR, is the negative reciprocal of 4. So it's negative and the reciprocal 1 over 4. So we now know a point on the line and the gradient, so we can form its equation. Its equation must be in the form y equals mx plus c, and we know that m is equal to negative a quarter. So we've got y is equal to negative a quarter x plus c. The only thing we don't know is the intercept c, which is here. Well, as we know a coordinate, we can put the coordinate into our equation. Here is our x value, and here is our y value, and solve for c. So I'm going to sub y equals 4 and x equals 1. So we get 4 is equal to negative a quarter, x being 1, plus c. Moving things around, c is equal to 4 plus a quarter. And the easiest way to think about this is, well, 4 is effectively 16 over 4, plus another 1 over 4. This turns out to be 17 over 4. So we now know the whole equation of the line. The point R can be found by substituting y equals 0. So let's try it. Sub y equals 0, and we get 0 is equal to negative a quarter x plus 17 over 4. Moving things around, a quarter x must equal 17 over 4. The over 4s cancel each other out, and I can say, therefore, x is equal to 17. So therefore, R is at, and an x-coordinate of 17 and a y-coordinate of 0. And that is your answer.